Hi friends, welcome back to our YouTube channel. Today we have to discuss about carry look ahead adder in computer organization and architecture course, digital electronics course, switching theory and logic design course. Carry look ahead adder is mainly developed for overcome the limitation of a ripple carry adder. First of all, what is a ripple carry adder? Suppose we are taking a 4-bit ripple carry adder. That means 4 full adders are connected in a series fashion. We are taking I plus 1th full adder. To perform the addition operation in I plus 1th full adder, it have to wait for the input carry coming from the output carry of the previous full adder. Okay, that means whatever the output carry that is generated from the ith full adder, that can be given as input carry for the I plus 1th full adder. That means I plus 1th full adder must have to wait for the input carry coming from the ith full adder. Once it is not coming, I plus 1th full adder must have to wait. This delay can be called as propagation delay. This propagation delay is 30 nanoseconds. Suppose 4 full adders are there, total 120 nanoseconds propagation delay is there. Okay, so to perform the addition operation between two 4-bit binary numbers, the propagation delay is 120 nanoseconds. Okay, to overcome that propagation delay, we have to use carry look ahead adder. It can also be called as CLA adder. In that carry look ahead adder, we have to perform the addition process very fastly by predicting the carry bits without actually calculated it. Because of that prediction, we have to perform the addition operation very fastly without any propagation delay. In the case of carry look ahead adder, all the carry bits are generated simultaneously for all the stages of the adder. Because of that reason, propagation delay can be reduced in the case of carry look ahead adder. Now consider the truth table of full adder. Here we are consider only carry output. Okay. Now in that truth table there are 3 inputs are there, A, B, Ci, where Ci is nothing but input carry. A and B are the normal inputs. Only one output is there. That output is nothing but C suffix I plus 1, that is output carry. So how to perform the addition operation, you already know that. Okay, so 0 plus 0 plus 0, that is 0. 0 plus 0 plus 1, that is 1. Some value 1, there is no carry is generated, so that carry value is 0. Here some column I am not considering. Next, 0 plus 1, 1. 1 plus 0, 1. Some value 1, there is no carry is generated, so that carry output is 0. Next, 0 plus 1, 1. 1 plus 1, 0 with carry 1. Okay, so that carry value can be taken as 1. Next, 1 plus 0, 1. 1 plus 0, 1. Some value 1, carry is no generated, so that its value is 0. Next, 1 plus 0, 1. 1 plus 1, 0 with carry 1. Some value 0, carry value 1. So, carry value 1 I have to write. Next, 1 plus 1, 0 with carry 1 plus 0. So, carry value is 1, some value is 0. Next, 1 plus 1 plus 1, 1 with carry 1. So, carry value is 1. Okay, here how many number of cases are there? Total 8 cases are there. How many number of inputs? N value is equal to 3. How many number of possible combinations are there? 2 power 3, that is 8 possible combination, 0, 0, 0 to 1, 1, 1. Among the 8 possible combinations, we are considering only 4 cases. Okay, this case, this case, this case and this case. Why these 4 cases we have to consider? In that cases, the output carry C suffix I plus 1 contains the value 1. So that these 4 cases we have to consider. Now, consider last 2 rows. In that last 2 rows, whenever A value is high and B value is high, then C suffix I plus 1 value is also high. Okay, that means output carry value is equal to 1 when both the inputs A and B are high. Next, in this case also, the output carry C suffix I plus 1 value is high when both the inputs are high. So here we do not consider the C input carry bit C suffix I. So in these 2 cases, the output carry C suffix I plus 1 depends only on both the inputs are high. Okay, next one. Now, this case and this case we have to consider. In that 2 cases, the output carry C suffix I plus 1 is high when the exclusive OR operation between the 2 input bits A and B value is equal to 1 and the C suffix I value is also 1, then C suffix I plus 1 value is high. Okay, here if A exclusive or B, that means 0 exclusive or 1, that is equal to 1, and C suffix I value is 1, then C suffix I plus 1 is equal to 1. So that means C suffix I plus 1 is depends on the exclusive OR operation between the 2 inputs A and B, and also input carry value is equal to 1. Here also same condition is applied here. Next one. Here in this case, if A and B values is equal to 1, then C suffix I plus 1 value is equal to 1. Okay, so these 4 cases we have to consider. Now we have to write the output carry equation. C suffix I plus 1 is equal to AB. AB is nothing but this case. When both the inputs are 1, then C suffix I plus 1 value is equal to 1. These two cases. So, C suffix I plus 1 depends on both the inputs are high. That means AB. It does not depends on input carry. Plus, next, this case, C suffix I plus 1 value is equal to 1 when exclusive OR operation between the two inputs A and B is multiplied with input carry Ci. Okay, so here AB can be called as carry generator. A exclusive or B can be called as carry propagator. Carry generator can be denoted by capital G. Carry propagator can be denoted by capital P. Okay. Now, this entire equation can be rewritten as AB is nothing but carry generator, that is G suffix I, plus A exclusive or B can be written as P suffix I, that is carry propagator. Then it is multiplied with C suffix I. This is the output carry equation in terms of carry generator and carry propagator. In the carry look ahead adder, we have to use two components. One is carry generator, that is nothing but G is equal to AP. Second one is carry propagator, that is nothing but P, that is equivalent to A exclusive or B. Okay, now put I is equal to 0. Put I is equal to 0 in that equation. After substituting I value 0, C suffix 0 plus 1 is nothing but C1. C1 is equal to I value 0 means G0 plus P suffix I is nothing but P0. Next, C suffix I is nothing but C0. So here C0 is nothing but input carry, where C0 is nothing but input carry. Initially, input carry value is equal to 0 in the 4-bit ripple carry adder. Okay, next, put I is equal to 1 in the above equation. In this equation 1. Whenever I value is 1 is substituted, it becomes C2. C2 is equal to G suffix I means G suffix 1 plus P suffix I is nothing but P suffix 1 into C suffix I is nothing but C suffix 1. We already know the C suffix 1 value, C1 value. Okay, without actually calculating, already it is calculated. So that we have to substitute here G1 plus P1 into, what is C1 value? C1 value here is there. G0 plus P0 into C0. That is nothing but G1 plus P1 G0 plus P1 P0 into C0. So this is the C2 value. So this is the C1 value and this is the C2 value. Okay, next, put I is equal to 2. Whenever we are substituting I value 2 in equation 1, then it becomes C3, so G2 plus P2 into C2. Now, we do not wait for C2 value, it is already calculated C2 value. Now, substituting C2 value here. Substituting C2 value, then we are getting G2 plus P2 into this value G1 plus P1 G0 plus P1 P0 C0. Then we are getting G2 plus P2 G1 plus P2 P1 G0 plus P2 P1 P0 into C0. So this is C3. Next, put I is equal to 3 in equation 1. Whenever I value is equal to 3, it becomes C4 is equal to I value 3 means it is G3 plus I value 3 means P3 into I value 3 means C3. Here we do not calculate C3 value. C3 value is already calculated. Only we can use it without actually calculate it. Then it becomes G3 plus P3 into what is C3 value here? G2 plus P2 G1 plus P2 P1 G0 plus P2 P1 P0 into C0. Then G3 plus P3 into G2, P3 G2 plus P3 into P2 G1, P3 P2 G1 plus P3 into P2 P1 G0, that is P3 P2 P1 plus G0. Next P3 into P2 P1 P0 C0, P3 P2 P1 P0 into C0. So this is the C4 value. So in this way we have to predict the carry bits, that is C1, C2, C3 and C4. Once we are getting the C1, C2, C3, C4 values, then we have to draw the logic diagram. Okay. Now this is the logic diagram of carry look ahead adder. So these are C1, C2, C3, C4 are the output carries. Okay. Now how it is how it can be drawn? First one, C1 is equal to G0. This is G0. P0 into C0. P0 and C0 are applied to two input AND gate. Then we are getting P0 C0. Then G0 and P0 C0 can be applied to two input OR gate. Then we are getting C1. C1 is equal to G0 plus P0 into C0. Next, how C2 can be calculated? So this is C2. C2 is equal to, this is G1. Next one, P1 G0. So this is P1 and this is G0. P1 and G0 are applied to two input AND gate. Then we are getting P1 G0. Next one, P1 P0 C0. Here This is P1 I am taking, this is P0 I am taking, this is C0 I am taking. So then we are getting P1, P0, C0 by applying 3 inputs to the 3 input AND gate. Then we are getting P1, P0, C0. Okay, we are getting P1, P0, C0, P1, G0 and this is G1. These 3 outputs can be sent to 3 input OR gate. Then we are getting C2. So C2 is equal to G1 plus P1 G0 plus P1 P0 C0. Now, how C3 is calculated? C3 is equal to first one G2. So this is G2 line. Next one P2 G1. So this is P2 line and I am taking this is G1 line. So P2 and G1 are applied to 2 input AND gate. Then we are getting P2 G1. Next one P2 P1 G0. So here I am taking P1 G0 line and I am taking P2 line. These 2 inputs send it to 2 input AND gate. Then we are getting P2 P1 G0. Next one P2 P1 P0 C0. Already P1 P0 C0 is there. I am taking this one and I am taking P2 here. These 2 inputs send it to 2 input AND gate. Then we are getting P2 P1 P0 C0. So now we have to combine them. So first G2, next P2 G1, next P2 P1 G0, next P2 P1 P0 C0. These 4 can be sent it to 4 input OR gate. Then we are getting C3. Next, how to get C4? C4 is equal to G3. So this is G3 line. Next one P3 G2. Here this is P3 line and I am taking this is G2 line. These 2 inputs send it to 2 input AND gate. Then we are getting P3 G2. This can be sent it to here. Next one P3 P2 G1. So here P2 G1 is there. I am taking this one. P3 I am taking here. These can be sent it to 2 input AND gate. Then we are getting P3 P2 G1. Next one P3 P2 P1 G0. So here P2 P1 G0 I am taking here. Next I am taking P3 here. So these can be sent it to 2 input AND gate. Then we are getting P3 P2 P1 G0. Next one P3 P2 P1 P0 C0. Already here P2 P1 P0 C0 is there. I am taking here. Next I am taking P3 here. These can be sent it to 2 input AND gate. Then we are getting the output P3 P2 P1 P0 C0. Now we have to combine them to 5 input OR gate. First one is G3, second one is P3 G2, third one is P3 P2 P1 G0, next one P3 P2 P1 G0, next one P3 P2 P1 P0 into C0. Then we are getting C4. So in this way we have to draw the logic diagram for the predicted carries C1, C2, C3, C4. Next we know the sum output formula. S suffix I is equal to Pi exclusive or Ci, where Pi is nothing but Ai exclusive or Bi. This is carry propagate. Okay, put I value is equal to 0, then we are getting P0 exclusive or C0. put I value 1 here. S1 is equal to P1 exclusive or C1. Put I value is equal to 2. Then it becomes S2 is equal to P2 exclusive or C2. Put I value is equal to 3. Then it becomes P3 exclusive or C3. Once we are getting the carry output C1, C2, C3, C4, add S0, S1, S2, S3 some outputs. Finally, we have to draw the block diagram. In that block diagram, only the outputs are S3, S2, S1, S0 and only C4. Okay, that diagram can be drawn here. Already seen the 4-bit binary parallel adder over a ripple carry adder diagram. What are the outputs in the diagram? That are S0, S1, S2, S3 and the final carry output is C4. So S0, S1, S2, S3 are called as sum outputs and the final carry output is nothing but C4. Next, what are the inputs are there? That are A0, B0, A1, B1, A2, B2, A3, P3 and input carry bit is C0. For 4-bit binary parallel adder or a ripple carry adder, the inputs are A0, B0, A1, B1, A2, B2, A3, B3 and the input carry is C0 and the outputs are, some outputs are S0, S1, S2, S3 and the final carry output is C4. Now, how to find out the final sum outputs S0, S1, S2, S3? Okay, for that one, the sum output formula is S suffix I is equal to Pi exclusive or Ci, where Pi is nothing but Ai exclusive or Bi. Now, first we have to find out the sum output S0. So, put I value is equal to 0 in that formula. That is S0 is equal to I value 0 means P0, I value 0 means C0, P0 exclusive or C0. Okay, here S0 output we are getting by taking the two inputs P0 and C0. These two inputs can be sent to two input exclusive OR gate. Then we are getting the output S0. Then here C0 is nothing but input carry bit. What is P0? P0 is nothing but A0 exclusive or B0. So here P0 is nothing but A0 and B0 are two inputs that are applied to the two input exclusive OR gate. Then we are getting the output P0. Next, G0 is nothing but A0 and B0 inputs are applied to two input AND gate. Then we are getting the output A0 B0 is nothing but G0. Okay. Next how to find out S1? So substitute I value is equal to 1 in that formula. Now after substituting I value 1, it becomes S1 is equal to I value 1 is nothing but P1, I value 1 is nothing but C1, P1 exclusive or C1. So S1 output we are getting by taking the two inputs P1 and C1. These two inputs are applied to two input exclusive OR gate. Then we are getting the output P1 exclusive or C1. That is nothing but S1. Next, how to find out the P1 value? So P1 is nothing but A1 exclusive or B1. So this is the P1 P1 is nothing but A1 and B1 inputs are applied to two input exclusive OR gate. Then we are getting the output P1 is equal to A1 exclusive or B1. Next, how to find out G1? So A1, B1 inputs are applied to two input AND gate. Then we are getting A1 into B1. That is nothing but G1. Okay. How to calculate C1? That is already calculated in the previously. In the same way, we have to calculate the C1 here. Next one. Next output is S2. How to find out the S2? P2 and C2 outputs can be sent. P2 and C2 inputs are applied to two input exclusive OR gate. Then we are getting the output S2. To get the output S2, substitute I value is equal to 2. So after substituting I value is equal to 2, we are getting S2. S2 is equal to, substitute I value 2, it becomes P2. Substitute I value 2, it becomes C2. P2 exclusive or C2. Okay, here P2 and C2 are applied to two input exclusive OR gate. Then we are getting P2 exclusive or C2 is nothing but S2 output. So what is P2 value? P2 is nothing but A2 exclusive or B2. Here A2 and B2 are the two inputs that are applied to two input exclusive OR gate. Then we are getting the output A2 exclusive or B2, that is nothing but P2. Then A2, B2 inputs are applied to two input AND gate. The output is A2 into B2, that becomes the G2. Here, how to calculate C2? That is already calculated in the previously. That value is substituted here. Next one. Next output is S3. How to get S3? P3 exclusive or C3. So P3 and C3 inputs are applied to two input exclusive OR gate. Then it becomes P3 exclusive or C3. It is equal to S3 output. How to get it? Substitute I value is equal to 3 in that formula. Then it becomes S3 is equal to, substitute I value 3 here. It becomes P3. Substitute I value here 3. It becomes C3. P3 exclusive or C3. So P3 and C3 are applied to two input exclusive OR gate. It becomes P3 exclusive or C3. That is nothing but S3. So what is P3 value here? P3 is nothing but A3 exclusive or B3. Here A3 and B3 are two inputs that are applied to two input exclusive OR gate. Then we are getting A3 exclusive or B3. It is equivalent to P3. Next, A3 and B3 are applied to two input AND gate. It becomes A3 into B3. It becomes G3. How to calculate C3? It is already calculated previously. Please check once. So these two can be sent it. We are getting the output S3. And final carry output is C4. How to calculate C4? That is already calculated. So C4 is the final carry output. S3, S2, S1, S0 are the sum outputs. And C1, C2, C3, C4 are already calculated previously. And C0 is the input carry. So in this way, we have to draw the logic diagram for carry look ahead adder. Now, what are the advantages? The advantage is nothing but it generates all the carry bits for all the stages of 4-bit ripple carry adder simultaneously. That means generates the carry bits for all the stages simultaneously. That is the first advantage. Second advantage, it reduces the propagation delay. That means we do not wait for the carry input from the previous full adder. Okay, So because of that reason, propagation delay is reduced. That means I plus 1 full adder does not wait for the carry output that is generated from the previous full adder, so that propagation delay is reduced. Next, disadvantages. To generate all the carry bits simultaneously, so that it requires complex hardware. Whenever it requires complex hardware, automatically it is costlier. Okay, when the number of bits increases, okay, so it becomes more complicated. The logic diagram and also more complicated. So these are the advantages and disadvantages of carry look ahead adder. I hope all of you understanding this video. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. If you really like this video, please subscribe my YouTube channel, Dirvela Srinivasa Rao. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. Thank you one and all for watching this video.